In this video, we'll talk about series circuits. The series components are connected one next the other. So in a series circuit, the components are connected next to each other, like a chain, as you can see here in the picture. Or here we have lamps connected in series. Each base is connected to the other directly through one wire, from one end to the other end. In a series circuit, there's no branches or junction. It is a single loop. That's why it's called a series circuit. For example, in a torch, we have a series circuit. Now, in a series circuit, one switch can turn all the components on and off together. So when we turn the switch on, you'll see that the two lamps are on. And if one bulb or other component breaks, it causes a gap in the circuit and all of the other bulbs will go off. So the gap made an incomplete electric circuit. The voltage supplied by the cell or mains supply is shared between all the components. So the more bulbs you add to a series circuit, the dimmer they all become. The larger the resistance of the component, the bigger the share of the voltage. So if a component has a larger resistance, it will take more voltage than the other components. Here we have a simulation. We have a black rectangle. It is considered to be a wire. We will put a battery of 9 volts, as you can see. Then we will add the switch, then the lamp, and if we turn the switch on, we will see that there's a conventional current passing through the circuit, and the lamp turns on. Here the unit to charge is leaving the battery, entering the lamp, giving it the energy of 9 volts. The lamp takes the electric energy from the charges and transforms it into light and heat energies. And if we turn the switch off, add a second lamp in series, we can see here that there's no junctions between the components. Now we turn the switch on, so both lamps turn on. The unit charge leaves the battery, it gives part of its energy to the first lamp, and the other part of its energy to the second lamp. So the main voltage is distributed between the lamps. If the lamps are identical, the main voltage is distributed equally between the lamps. So let's say the voltage of the battery is 9 volts. Each lamp will have a volt of 4.5. So U, which is the total voltage, equals to U1 plus U2. U1 corresponds to the voltage of the first lamp, and U2 corresponds to the voltage of the second lamp. Now let's move to measuring the voltage using a voltmeter connected in parallel to one of the lamps connected in series. We have a battery cell, open switch, and 3 lamps. We have an open switch, so there's no voltage in the current. If we close the switch, the current passes through, and the voltmeter is now reading 3 volts. Now let's say the voltmeter is connected to 2 lamps. It will give the voltage of the 2 lamps connected in series, which is 6 volts. So each lamp has a voltage of 3. Now, if we turn off the switch and turn the voltmeter to measure the voltage of the 3 lamps, and then close the switch here, the voltmeter gives 9 volts. So total voltage, or the main voltage, U equals U1 plus U2 plus U3. U1 corresponds to the first lamp, U2 corresponds to the second lamp, and U3 corresponds to the third lamp.